In this video, we are going to be looking at determining the reaction order for a reactant in a rate law using graphs. And so I have prepared a table that has time versus concentration for the decomposition of chlorine monoxide. So I'm just going to, we're going to include what the reaction is. So this is chlorine monoxide gas, and it is decomposing. So it's a decomposition reaction, so you have one substance breaking down into two. And so the only thing that this thing can do is it can break down into elemental chlorine and elemental oxygen. And so a rate law for a reaction, so this is our reaction, a rate law is equal to K, the rate constant, times the concentration of your reactants raised to some order. And so right now we don't know what that order is. If this was a one-step process where two chlorine monoxide molecules react with each other and in the end they end up as just chlorine and oxygen, then it is just an elementary step. Or it could take place over a series of steps with some intermediates. So this reaction was monitored over time, so we got milliseconds and molarity. And so if you have a reaction that is monitored time versus concentration, you can graph the data to determine the order. And the way that you do this, if it is a first order reactant, then you're going to graph time, which is your x-axis. So all the time is going to be your x value versus the natural log of your concentration. And so our substance is chlorine monoxide, and this is going to be your y-axis. So we are going to mathematically change the molarity. We're going to do the natural log of each of these. If it's linear, if this graph that is the time versus the natural log of the concentration, if that is linear, then ClO is a first order reactant. And your rate constant will be equal to negative the slope. If it is a second order reactant, then you're going to graph time, again that's your x value, versus 1 over your concentration. If this graph is linear, then ClO is second order, and K is equal to the slope. So your rate constant is your slope. The only way that you can determine if it is first order or second order for this problem is to actually graph the data. So I'm going to use Excel, and we're going to go through and I'll explain what you do with the data in Excel. It's similar if you use Google Sheets. You need the Excel to be a version that you download, because some of the ones that are online do not do the type of linear regression that we want. So I'm just going to take this data and see if I can copy it. When you put it into Excel, you want to always have the heading. It does not paste. Okay, so I chose too many. Okay, so my I put my data in, time, and then I'm going to put my concentration data in. I'm going to show you this so that you can know how to put scientific notation. So You want to put a heading. I'm going to make this be centered so it's not in the way. So to use scientific notation in Excel, you type your number first and then you just do the letter E, and Excel reads that letter E as times 10. And then you do -8. And so that reads it as scientific notation. So the next one we would type 7.19 E -9, and then 4.74 E -9, 3.52 E -9, 2.81 E -9, 1.27 E -9, and the last one, it's not in proper scientific notation, but I'm just copying it over as it was written. And so I'm typing in 0.66 times 10 to the -9, E -9. Don't type times 10 into Excel. What it does when I hit enter, it will fix it and make it the correct format. So watch that. It went to 6.6 times 10 to the -10 because that's correct scientific notation. So here I have my time data and my concentration data. I want to graph time. I'm going to copy it over and put it here versus the natural log of CLO. Now if you wanted, you could go and use your calculator, and every one of these pieces of data you could take and type that number in and do the natural log on your calculator. But Excel acts like a calculator, and so you have to tell it what you want it to be equal to in that cell. And so you can type in formulas. So the first thing you would do is you would type equals, and then ln is the natural log, and so I'm going to do parentheses, and I'm not going to type the number. I'm going to go over here and grab this cell, and so what it will do is it'll take the natural log of what's in the cell B2, and if I hit enter, it takes the natural log of that number. Now you don't have to do this with all of these, because every one of these data points, it comes from the data point for the concentration that was just in that other column for concentration, in the B column. And so if I want to do this one, all I have to do is go and grab the corner of the cell above it and drag it down, and it translates the formula one cell down. And so it rewrites the formula, but it makes the formula be for the data point that came from B3, and this one came from B4, and this one came from B5. So these are the natural log values. To graph this, you want to choose your X column first, and I just moved the X column over so they're side by side, but it has to be X and then Y. And so you choose your X column first, and then you choose your Y column, and then you're going to insert a scatter plot. And if you look at this, I'm looking to see if it's linear, and this does not look linear at all. If you're not sure, you can highlight the little dot, and if you move this over, you can go to this little plus sign and go to trend line, and you can look and see, does your trend line look linear? It does not. It's not hitting any of those points, and so this is not linear. So I'm going to put over here, this is not linear. So let's just hope that the next one is linear. So because it's not linear, therefore CLO is not first order. Okay, so I'm going to move this. Now I'm going to figure out if it's second order. So to figure out if it's second order, we're going to graph time versus the inverse of the concentration. So again, I'm going to take my time data, and I'm going to copy it and put it in another column. And then next to it, I'm going to put the Y value, and my Y value is 1 over the natural log of, or 1 over the concentration of CLO. And so again, I want to mathematically change my original molarity value. So you can do it on a calculator, or you can just have Excel do the calculation for you, which is what I would recommend. It's less to transcribe. So to make it do math, you just tell it what to do. I want this cell to equal 1 divided by, and then you go over to the concentration data, which is here, and you grab that cell like this, and then you just hit enter. And it changes the concentration. It does the inverse. To make it do this for all of the values, you just drag down the formula. And so every one of these, if you just look, that is the inverse of the information in B3. That is the information from B4. That is for the information of B5, B6, B7, and B8. You want to be sure that you get this information. You do not want the inverse of time, and you don't want the inverse of the natural log. You want the inverse of this concentration. So that's why it's really important to put headings so that you know what all these numbers correspond to, because they're not numbers, they are some kind of measurement value. So again, you want to insert a graph, and so you want to choose your x-axis first, and then choose your y-axis. Insert a scatter plot. So you want to do a scatter plot. Do not do any other versions. It needs to be scatter, and then you're going to add a trend line. So you want to highlight the dots and go over and do the little plus, and you want the trend line, and you want to look at it, and this looks linear because the trend line goes through the dots. The one that is closest to all the dots, that would be the one that is the closest to being the order. And so this graph is linear. Therefore, CLO is second order. So I can change my rate law, or I can rewrite it. So I'm just going to type it over, go down here and copy it. And I know what this is now, so I'm going to change this to a 2 because it's second order. Now from your graph you can find the slope. So all you need to be able to do is see what the y equals mx plus b is. And so if you go over here and you go to your trend line and you go to the little side, you can go to more options. The more options you want, you just want to display the equation on the chart. The reason you want to display the equation on the chart is because you want to see what the slope is. And so the only way to see what the slope is to actually look at what the linear equation is. Okay, so I'm just going to move it up here. Move it right there so you can see it. If you look, this says 7 times 10 to the 6th. That is the slope. But 7 is the number part, and that is one significant figure. And so if you ever look at either a decimal number or a scientific notation number and you just see one digit, so leading zeros are not significant, and then the times 10 to the 6th, those are not significant zeros. This is just a one significant digit number. This is not good. That's not good chemistry. And so what you can do is you can go to label option. So you have to have the label highlighted. So if you move it around, it'll be highlighted. If you go over here to where there's the bars, this is actually the label options, and you want this to be a scientific notation number, and you can change the number of decimal places in the number. And so just by putting in scientific notation, it just automatically did 2 digits. And if we look, all of our measurements, and they're all at least 3 digits. So the time was 10.0, 20.0. Those are 3 digits. This is 3 significant digits right here. 7.24 times 10 to the 6. That's 3 digits, so that's fine. But 7 times 10 to the positive 6 is not fine because that's only one significant digit. Again, to change it, you just want to make sure that the label is highlighted, and then you can either right-click. You can right-click and go to Format Trend Line, or if this information, if the little sidebar is present over here, you go to the little bars, and that will change your label options, and you just go, what kind of number do you want? You want a scientific number, so that's scientific notation. And so our linear equation, I'll copy this. Okay, here's our graph with our linear equation on it. And so our slope is our k, which is our rate constant. So right here is the slope. So k equals, not big K, I need little k. And I'm not going to, that's not the way we write it. We don't say E. We type it times 10 to the 6th power. So that would be the rate constant. So that's how we use a graphing data, and you only graph time versus concentration. One other thing that you can use Excel to do, we have this data here, so you might as well. I'm going to delete all of the new data and so that it's out of the way. You can also have Excel do anything that is mathematical. And so if we want to calculate the average rate of the CLO reaction, then average rate is your change in concentration over your change in time. So it's, if you're looking at just a normal graph, you're just doing the normal graph. So this is just a normal graph, time versus concentration, no changes at all. So here's all the concentrations, here's all the times. This is not, we haven't done anything mathematical. The average rate is just the slope between two data points. So from here to here, if we did change in your y value over change in your x, that's just the slope for those two data points. So average rate is just simply a slope between two data points. So data point, that data point there is 0 time, here's your concentration. So this is your x value and your y value. So to get a slope, you have to go to your second data point because you need the difference in two data points. I'm going to start it here because the first one, there's not going to be a slope for the first point by itself. So the difference between these two. So to make Excel do what you want, you just have to tell it. And so you need a top value. So I want the top value to equal, and it's going to be the difference in your second data point and your first data point. So you go over and you grab each of those, and then it'll be divided by your change in x values. So the x values that went along with that was 10 minus 0. And you hit enter. And here is your average rate between the data points 1 and data point 2. Since I put in a math formula, you can go and you can grab and bring it down, and you can see each of these average rates. You'll notice that the average rate goes down and gets slower. And you can see that. This is a very steep slope. This is a less steep, less steep, less steep, a lot less steep, a lot less steep. As you go through a reaction, you have less and less reactant. And so the lower the concentration of your reactant, the slower the rate is. That's evident in these numbers here. So in between each of these, the average rate would be just the difference in two data points. So that's why this one's blank. You'll only have average rates starting at the second data point because it's the second data point minus the first one, and then the third minus the second, and then the fourth minus the third, etc., all the way down. So in this case, we had 7 data points. We have 6 averages. The reason it's negative is because it's a reactant and that substance is disappearing. And so if it was a product, it would be a positive average rate, but the rate itself is just 7.81 times 10 to the negative 10. The negative just means it's the rate of disappearance. So that is another thing that you can use Excel to do if you have time versus the amount of a substance.